Pairwise comparison is used to compare each candidate to each of the other candidates. You can think of this as a head-to-head comparison. Using the voter's preferences, you can look to see which candidate a voter would prefer if only given the choice between those two candidates. Once all the comparisons are done, a point is assigned to the winners of each comparison. If there are ties, then the candidates would get half a point each. For this example, we have the preference schedule for a Portland City Council election. The candidates are labeled E, F, G, H for convenience. When comparing the candidates, we want to make sure each of the candidates get compared to each of the other candidates. Let's start with candidate E. We're going to compare E to each of the other candidates. We'll start with E and F. If a voter were only given the choice between E and F, based on this preference schedule, we can determine who would win between that election. I'm going to go ahead and highlight all of the E's green, and then all of the F's purple so that it's a little easier to see the comparison. And then we're just going to ignore the rest of the schedule as if they don't exist. So we're only looking as if the election were between E and F only. In this first column, looking at these 11 voters, they would prefer E over F. So we'll give those voters to E. In our next column, we have 8 voters who would prefer F over E. So we'll give those votes to F. Next, it looks like I accidentally erased F. So we have 3 voters who prefer E. And then our next column, we have 9 voters who prefer F. And we're just looking at each column, looking to see who those voters would prefer if they were only given the choice between those two candidates. For the next one, we have 14 for F, and then 9 voters prefer F in that last column. So if we have these numbers here, we can add those up. I apparently can't move it, so we're just going to rewrite them here. 11, 3, and 16 gives candidate E 30 votes. 8, 9, 14, and 9 gives candidate F 40 votes. So in this comparison, if the voters only had the choice between E and F, then the voters would prefer F as the winning candidate. We need to do this for all of the options. So the next one we're going to look at, we just did F. So what if the voters only had between E and G? Who would win that outcome? Once again, I'm going to highlight E in green. And this time I will highlight G in purple, ignoring the rest of the table. So once again, we'll go column by column and decide of those votes available, who would have earned those votes if these were the only two candidates. So in this first case, E is preferred over G, so E gets the 11 votes. I do want to make note that we know E preferred, or we know that E is preferred over G because they were chosen as the first place choice versus G is the fourth place choice. So the preference table is already listed by top choice down to last choice. And so we're just looking to see which of these are on top. And we know those will be the candidate who is preferred over the other. So our next column, we have 8 voters who prefer G. And our next column, we have 3 voters who prefer E. And then 9 voters who prefer G. 16 voters who prefer E. And it looks like E is preferred by the last 2 columns as well, with 14 and 9. I don't need to add these up to determine who the winner is. In this case, we can see by far E is going to be the winner of that comparison. And I'm erasing so that I can have enough space for all of these comparisons. But you would probably want to keep yours on your paper rather than erasing. Now we're going to compare E with our last candidate. There are 4 candidates. We compared E with F, and then we did G. Now we need to do H. This time I will strategically erase, and I will highlight H in purple. And we can see that for our first column, the 11 voters there would prefer E over H. The next 2 columns, those 8 and 3 voters would prefer H over E. So 8 and 3 is 11 as well. The next column has 9 voters who would prefer H. And then the next one has 16 voters who would prefer E. Our next one is 14 voters who would prefer H. And then our final column of 9 voters would prefer E. So if I add those up, 11, 16, and 9, I get 36 voters prefer H, and then 11, 9, and 14. It's a close one at 34, but E wins those votes. And I can check to make sure I didn't miss any voters by making sure my sums add up to the same number. So when I add 30 and 40, I get 70, and then 36 and 34 give me 70. If I add these numbers up, we also get 70. And that's just one way to double check that you didn't accidentally miss a voter. So now that we're done comparing candidate E, we've done all the possible comparisons with E because we compared E to F, E to G, and E to H. So we're going to move on to candidate F, and we're going to do as many comparisons as we can for F. And as we mentioned, F and E are already compared. So we're going to go ahead and compare F with G. Let's see, F, I'm making green, and we'll make G purple. And then we can start looking at who is preferred between those two. So we have 11 voters who prefer F. We actually have in all 3 of these, all 3 row columns here prefer G over F. So that is 11 and 9, which is 20 who prefer G. Oh, and then also this one also prefers G. So that's another 16 for G. And it looks like the last 2 columns prefer F. So F will get 23. And if I add those numbers up together, we can see that G is preferred over F. Oh, those are connected, so I can't move them. That's fine. Now I've already compared G, so now I'm going to compare H, F versus H. Let's erase the G's and instead mark our H's. In our first column, those 11 voters prefer F. The next two columns, these 11 voters prefer H. And then these 9 prefer F. The next 16 prefer H. And then the last 2 prefer F. So we have 43 and 27. So now we've taken F and we've compared it to E, we've compared it to G, and we've compared it to H. Those are our other 3 candidates. So we're done comparing F. So now we can compare G with all the other candidates. We already have G compared with E, and we have G compared with F. So the only one left to compare G with is H. So let's do that one. Start with G for green, or green for G, and then purple for H. And it looks like for the first 3 columns, H is preferred over G, so that would give us 22. The next 2 columns, we have G preferred over H, which would give us 25. The next column, H is preferred for 19, and then for 14. And then the last one, G, is preferred for 9 votes. This gives us 34 votes and 36 votes, giving H the most votes between those comparisons, meaning that H would be preferred over G. Now, I've gone through and done all the comparisons. There are no ties, and so I don't need to worry about awarding half points, but I do need to go in and actually award the individual points based on who won which comparison, so that I know who the winner of the actual overall thing would be. So E is highlighted 2 times, so E gets 2 points. F is highlighted 2 times, so F also gets 2 points. G is only highlighted once, so G would get 1 point. And then H is only highlighted once, giving H 1 point. So in the case of this election here, which is a theoretical, not real election, we find that E and F, if using the pairwise comparison method, they would tie for this election, which means there would probably need to be some other form of tiebreaker or another way to analyze these votes. Hopefully this helps with understanding the pairwise comparison voting method.